Today we're going to talk about hypothesis testing. This is part one of a two-part series, and all we're going to work on in this series of lectures and PowerPoints is forming hypotheses. And the reason it's going to take a whole series of lectures and PowerPoints is because it's convoluted, y'all. But still, this procedure we will use, called null hypothesis testing, is the most widely used hypothesis testing procedure in the world. It's used by psychologists, biologists, anthropologists, sociologists, nurses, physicians, exercise scientists, and just about anyone who engages in research. It all starts with a question. And from the question, we're going to form a research hypothesis. And from the research hypothesis, we're going to form two statistical hypotheses, the null and the alternative. We're going to test the null, reject or fail to reject the null, and form conclusions. That's not a question for science. What? We need to start with a question that can be stated in terms of parameters and then tested. Here's a question we can answer. And here's another. Okay, so we have a couple of questions. From the question, we form a research hypothesis. We need to be careful about our wording of our research hypothesis because it corresponds to our question. So we need to read the question and form the research hypothesis exactly in the way the question is asked. When we form the research hypothesis, we need a specific, clear, and testable statement about the expected outcome of the study. And this statement usually has to do with there being an effect. We usually expect differences. To go from a research question to a research hypothesis, we're just going to turn the research question into a statement. From the research hypothesis, we'll form two statistical hypotheses. The null hypothesis, we're going to represent that as H sub 0, nothing, not, 0. And the alternative hypothesis, we're going to represent that with an H sub A. Statistical hypotheses have to do with relationships between parameters, and we represent those relationships with signs like less than, greater than, less than or equal to, not equal to, equal to. Non-directional hypotheses do not specify a direction and result in two-tailed tests. These relation symbols correspond to words like different, more or less, not the same, so not equal to. Directional hypotheses do specify a direction and result in one-tailed tests. The words that you look for to know that you're dealing with a directional hypothesis might be greater, lesser, more, less, higher, lower. So now we need to move from a research hypothesis to two statistical hypotheses, the alternative and the null. A statistical hypothesis, written in terms of parameters, that postulates the existence of a treatment effect or a relation among variables is called the alternative hypothesis. The alternative hypothesis, H sub A, corresponds to the research hypothesis and is an alternative to the null hypothesis. So you figure this out. Is this a directional or non-directional research hypothesis? When we move from a research hypothesis to a statistical hypothesis like the alternative hypothesis, we remove the words and tell our story what we think will happen with parameters and symbols. The null hypothesis is a statistical hypothesis as well. The null hypothesis is a statistical hypothesis that is to be nullified. We're going to test the null hypothesis. It usually indicates no difference or no difference of interest between two parameters or between one parameter and a specified value. There are three possibilities with regard to the relation between mu r and mu ds. It may be that mu r is greater or lesser than mu ds, and in any case, if either of those are true, then mu r and mu ds are not equal, just like we postulated in our research statement and alternative hypothesis. So those possibilities and probability spaces are taken up with the alternative hypothesis. The only other option is that mu r and mu ds are equal. The null hypothesis is everything that the alternative is not. So the null states that the two parameters are equal. Let's work through the next scenario. We expect to find that women in the Deep South eat more sugar than the recommended 6 teaspoons per day. Your turn again, directional or non-directional, and state the alternative hypothesis. So this time we have a directional hypothesis in the alternative. Again, the probability space has three options. The alternative hypothesis covered the space where recommended sugar intake is less than Deep South sugar intake. So it must be that the null, every part of the probability space that is not taken by the alternative, is that the recommended sugar intake is greater than or equal to Deep South sugar intake. So we did it. We went from a research question to a research hypothesis to two statistical hypotheses. The alternative hypothesis, which is based on the research hypothesis, and the null, which is everything the alternative is not. Great job, guys. And you'll see some scenarios, the ones that follow in your homework, for practice.